Hello from a very smoky Chelan area, Lake Chelan. That's the BB Bridge crossing the Columbia River over my shoulder. And as we swing around here, we realize that we have a very dramatic rock outcrop along a highway, the Chelan Migmatite complex. That's our topic today. Thanks for joining us. Let's get started. Okay. All right. This Chelan Migmatite is so complicated that I think, in part, it's avoided. I don't know, I might be wrong about that, but I get the feeling that this unit is kind of overlooked. And there have been a few geologists over the years who've been working carefully with this, but I don't see the Chelan easily plugged into some of these regional questions we've been talking about. Well, this will be a fun little experiment. I haven't used my zoom that much on this iPhone 13 with an outcrop like this, and we'll see how crisp we can get from across the way. Yeah, that's where we want to go, right there. What the heck? What the heck? Amazing. Nice and quiet right now. Let's keep it going, boy. Keep it going. Just give you some visuals. I think this is one of those road outcrops that are more impressive from a distance than they are when your nose is right on the thing. Yeah, I'm liking this. So I think I'm just trying to get your interest and maybe have you try to think in real time with me, like what does this look like? Have we dealt with anything like this before? I mean, we've dealt with the Skagit gneiss earlier this summer. We've dealt with the Swakane gneiss. Is this a simple gneiss, like where we see banding, black and white zebra stripes? I guess yes, on this scale. But we're not calling this the Chelan gneiss because of the complicated, and maybe it's even appropriate to say rare, patterns, textures within this bedrock unit. The two black things are Eocene mafic dikes. And there are hundreds, maybe thousands of these basaltic feeder dikes that are cutting through much of the North Cascades, including the Teanaway basalt feeder dikes close to home. Not really our topic this winter, and so therefore not really my topic today, because that's too young for our story. I'm mostly interested in the Migmatite itself. Can I dust off my memory what we do know about this Migmatite? Can I also ask some maybe provocative questions for me and maybe all of us before we sign off here today? Let's look at some hand sample of this Migmatite. So ideally we'd be breaking off rocks right on that face, but for obvious reasons I don't think we'll do that. This is clearly material that was blasted off of that face. And so I feel like it's a decent approach to give you some hand sample look. And let's go ahead. Nope, that's much too hard. This is tough material. So is this like the Entiat Pluton? No, it's not. For one reason, we have a fabric here. You can see the black and the whites. The black and the whites have some organization to them. I hope you can see that. So it's not a homogeneous Pluton like the Entiat. Is every sample like that? Well, no. Let's keep going with some hand samples to look at. So glad I brought my hammer today. I think it's safe that just in this small little area, if I keep playing, I don't have to break this one open. I can just hold it up, I think, if I can lift it. I think it's safe to say that almost every block of this Chelan Migmatite is going to look different. And that's, I guess, part of the frustration when you're trying to teach or when you're leading a field trip and you're out here looking at this material. I don't know, can I get down there without wiping out? Yeah, I think I can. Let's try it. I mean, look at these blocks. Without going to my notes and my detailed information for you yet, let me plant the seed with you that this material is old. This is older than the other stuff we've been looking at in the Chelan block. It's generally older than stuff in the Wenatchee block as well. And now that I say that out loud, the Napiqua is pretty old stuff, right? But just as far as kind of these orthogneisses or plutons, we're older than 100 million years ago for some of this stuff, which is kind of new for us. And I'm remembering, just kind of standing here with you right now, that as I was talking about the 3 magmatic flare-ups in the North Cascades as framed by the Dream Team, which is the main way that we organized ourselves this past winter. Chris Mattinson had been following along with each of the episodes. At one point came down the stairs and dropped into the office, and he said, "I'm really enjoying learning a lot, but there is a 4th magmatic flare-up, and it's older than the 3 you've been talking about, and it's the Chelan. You really aren't addressing the Chelan." And these plutons that are older than 100 million years old. And to be honest, that kind of frustrates me because it kind of screws up the story in general as we've been discussing it. Because you remember last winter we were dealing with the first of the 3 major magmatic flare-ups in the North Cascades happening in response to some main event 100 million years ago. Remember, Mount Stuart Batholith and others, Tent Peak Pluton, were in the 90s. 91 million years ago, 95 million years ago, 96 million years ago. Well, this stuff has evidence of plenty of magmatic formation or magmatic generation older than 100 million years ago. Come on, Gizmo. Beautiful stuff. And if you're a rock collector and some of these look good to you, they're right here. There's no problem. There's right here. Oh, I can't stop. Look at this. Don't fall, boy. My heavens. Sexy rock, if there ever was one. Or words to that effect. I keep my eyes continuing to be drawn to certain things. I'm about to turn the camera off and then I see the next block. Wow. So have I gotten you curious enough about the Chelan Migmatite? I hope so. We'll finish with a couple of wide shots of the face, and then we will, I think, move. We'll try to drive to a quieter place without road noise to learn together. And for all I know, this will be the only thing we'll do in the episode, because there's a lot to absorb here, a lot to address. Terrible light for long distance shots, but I think quite good light for what we're doing here today. Can't stop. Cannot stop. My heavens. I'd forgotten how impressive this stuff is. I mean, I knew it was intricate. I don't think I've spent the time to come over at this lip before. Hell, even from here you can see some of the amazing migmatitic textures of some of those blocks down there. Holy cow. I'm not normally this guy. Once I've gotten a sense of the rocks for a unit, I don't go on and on, but it feels like every block is different. I guess that's the point. God. I mean, I just don't think we've seen anything like this summer. What have we seen that's even close to this? This level of complexity. We've seen some gneisses before, some metamorphic gneisses, but not like this. And then every sample is different. I keep saying that, but my God. If you're a rock collector, this place is a dream. And if you're trying to do some basic geology with a general audience, this place is a nightmare. I don't know, I'm kind of half kidding, but thankfully we've had 2 generations of Mattinson family geologists working here, Cliff Hobson, a number of other geologists that don't come to mind at the moment, but they have done some work. And I think my humble goal is to see if I can plug some of this work that has been done into some of the regional storylines that we've been trying to establish, not only in preparation for this winter's Baja BC series, but the last couple of A to Z series as well, the exotic terrane A to Z and the crazy Eocene A to Z. Can't hold it. I gotta get you on the face here. Come on. This stuff's too good. And you're like, is the guy ever going to start talking? Isn't he going to start teaching us stuff? No. Why not? Well, I don't really know what I'm looking at. And I prefer to keep my mouth shut when I don't know very much. And instead I prefer to do the reading of the professionals who have worked and have written. Goodness sakes. And you're like, well, where are we now? Well, we're at the same place, man. I just crossed the road. I walked through a bunch of garbage to get here. This is it. We just got our nose on it now. Oh, dramatic. Okay, this is Geology 101, right? Different generations of stuff going on here. The white thing is older than this gray thing. Why? The gray thing cuts across the white. The white had to be here first. Oh, man. I really forgot how good this is. Jeez. I got to come here at like 4 in the morning or something in the middle of summer when there isn't all this traffic. It would just add to the experience, but I can ignore the noise, I think. I can't stop. I got to keep showing you stuff. Am I wasting your time? I don't know. You can click off, I guess. You can click off, go on to something else. Just as a regular dude who, likes patterns. Like, I like patterns. Like, I have the same fascination at the moment as I suppose a kindergartner would. It's just like, oh, cool. Okay, I could do this for hours. Let's do one more little spot. Yeah. At some point, it looks like hieroglyphics. Impossibly complicated geometries. How in the world are you supposed to do anything with this? And how can you zoom out intellectually to a scale that can help us use this Chelan exotic terrane as it sits with a regional story? I have a couple of ideas, and that's what we're going to do next. Thank you for your patience. Okay, more of same, but different location. Maybe 4 minutes from where we were just a second ago on the busy highway, but now we're into a quieter spot. A place called BB Springs Recreation Area. I don't know, something like that. And an ice story here, but trying to stay focused. We're not talking about ice or the ice age until next spring. And so, as promised, let's sit and do some thinking, some talking, some reading. I can rest my feet right up against the Chelan Migmatite complex. So let's start with one of my favorite all-time maps that I was using last time as well. What did I do today? Again, I left Ellensburg. I got to Wenatchee. I drove up the Columbia River, US 97, left the Swakane, crossed the Dinkelman Detachment, crossed a little sliver of Nepequa, crossed through some Eniat Pluton, that was in the last video, crossed into this. On this map, it's pink with the blue X's, Chelan Migmatite. And yes, I'm at the town of Chelan right now. And you're like, I'm in France. I don't know what Lake Chelan looks like. Show me. Not today. Too foggy, too smoky. Okay, so the first point is that the Chelan Migmatite is another one of these exotic terranes that disappears underneath the German chocolate cake, so there certainly is much more of it that we can't see anymore. Second point is, what kind of connection do we have between the Chelan Migmatite, which we were just looking at, and the Swakane, or the Nepequa, or the Skagit, or any of these? And then, you know, even though I know a little bit about the Chelan Migmatite, as we'll get into right now, I don't know much. And then once we get north of there, and we're into the Methow block, and the Okanagan block, forget it. I don't know a damn thing, or close to it. So, and this is far enough away from home where I'm just not busting up for a day trip. So, I don't know if I'm going to get serious or not before November. But possibly I'll get up and spend an overnight in the Methow or the Okanagan block or both or something. But boy, my knowledge just drops off the face of the earth once we get up that far. And that's part of what I want to do here with you today. Okay, well, this is the Chelan 30 by 60 minute map, Roland Tabor. Different scale now. Swakane, Nepequa, little town of Eniat here. Continuing north. This is all Eniat Pluton. Earthquake Point, Eniat Pluton. Ribbon Cliffs, Eniat Pluton. We cross into this other shade of bluish grayish. Now we're at the Chelan, and Chelan where we're sitting now is right over here on the edge of the map. So, pretty significant block of this Chelan. From 2 years ago, yeah, I found all these old papers now. Kind of proud of myself. So yeah, we're at the Chelan Migmatite today, and if you've been following along with me all summer, you know, here they are. Ingalls, Chewaucam Gray, Swakane, Nepequa Schist, that was the last video. Don't have the Plutons on this now. That was my approach 2 years ago, to ignore the Plutons and just focus on the fruitcake itself. And yes, the Chelan Migmatite is a significant portion of the fruitcake. Here are some students of Chris Mattinson, grad students who go to Central. This is a few years ago. And on the banks of Lake Chelan itself, all sorts of details. Now, Chris Mattinson is a detail-oriented gentleman, which is crucial for this unit because there's so much to get into. you know enough about me where I'm not typically a weeds type of a person, so that's for better or for worse. Going back to the last show, since I found these pages now yesterday in the lab room, this is the Nipiqua from last video, and yes, those are the dates we were using, and yes, this is an ocean story with deep ocean siliceous sediment that's converting to chert, and then we get into some amphibolite and even an ophiolite, which I'd kind of forgotten. And so the notes, it's kind of dumb to show you this in this video, but whatever, I just found the pages. These are the notes from 2 years ago where I was in the backyard doing live streams, and we said, so this is kind of review of the last video, heterogeneous, a complex, metamorphosed chert, metamorphosed basalt, now called amphibolite, and schist, scraps of marble, scraps of ultramafic, potentially some kind of a subduction complex, but I don't know if we have to have that. I'm gun shy now after dealing with Daryl Cowan a little bit. Super amateur hour now, but this is me a few years ago trying to put the Lake Chelan. So we're sitting at the sea here. Yes, Chelan Migmatite, but there's that Indiat, Nipiqua, and Swakane from the last 2 videos. And there's a discussion about the deepest part of Lake Chelan coinciding with some of this quote-unquote softer schist, which I guess is Cascade River schist, which I'm probably going to lump in with Nipiqua since it's a deep ocean story. And then here's Bob and Stacia, Skagit Nice. Not far to the north is the North Cascades Highway, which a lot of people have been watching, by the way. Kind of fun to see that. Really kind of scrambling through. I am leading to something, believe it or not. Sure, why not? Here's from the cardboard box 2 winters ago. And looking at time here first of all, so we're going back into the Mesozoic. And this was my best attempt. Do you remember this? Are you a long-time viewer? If you're a new viewer, I did 26 exotic terrain shows in the fall/winter of 2020. And I was trying my best to do some basics with these exotic terrains. So Nipiqua, Cascade River, Skagit, Chelan, all apparently have this Triassic beginning, all representing some kind of an oceanic scene. Now, the wind is picking up, so I'll just kind of give you a chance to read that. And then this part of the crystalline core, including the Chelan, is doing this elevator thing. Okay, we're finally there. I'm reminding you that we have a protolith out in the ocean. We accrete this stuff, not sure when, but typically younger than 100 million years ago, the stuff starts getting dunked down the geologic elevator and then pops back up during the Eocene. Speaking of that, so happy I still have these. I kind of forgot if I threw those away or not from 2 years ago. So yes, if you're a fan, or at least you're intrigued by the geologic elevator business that continues to be a theme, and it cannot be avoided with the North Cascades. Yes, the Chelan is one of the 3 major exotic terrains that are doing the down and the up. But as I was indicating back at the road cut a second ago, notice the down and even the up of the geologic elevator for the Chelan Migmatite is ahead of everybody. Nobody seems to have an idea why. If we're really going back to the archives, this is notes that I took on the Chris Mattinson trip up here in 2016. So first of all, I've just learned an incredible amount since 2016. I was totally brand new to these concepts. So I joined the new grad students in September of 2016, and this is what we were on. Yeah, we were at that spot in 2016. Most of those notes correspond with what we were doing last time. Yeah, we were looking at the Eniat Pluton. I don't remember where we stopped. This is more or less what we also talked about in the last show. But here we go, yes, on September 11th, 2016, here are my notes as I'm right here at this spot. Yeah, this is what I called the striations outcrop. There's some glacial striations that cover this surface. So Chris Mattinson lectured right here to us and helped us realize that a migmatite is a mixed rock. There's plagioclase, quartz, hornblende, and biotite. There's some pyrite in here. There's some epidote in here. The major rock types are amphibolite, which is a former basalt, tonalite, which is a certain brand of granite, and basalt. So in a way, this is similar to the Napiqua, but we're going to see some differences here pretty quick. Cross-cutting relations. Okay, here's the main difference. It's the early version of my notes. Stuff for stop. Another stop. This is what I kind of ended up with on that field trip. Let me flip you around for a second. So, you know, when I'm on a field trip, I think it's frustrating sometimes for the leaders. I keep my mouth shut for the most part. I try to be respectful and give everybody a chance to be part of the experience, especially if there are students involved. But there's a point eventually where I can't keep my mouth shut. And I think the frustration part is that I push a rather simple narrative, a simple story that I have brewing in my mind as I'm imagining how to communicate some of this stuff to you or on a video of some form or both. And so I remember showing this cartoon to Chris, and he's kind of like, ooh, okay, nice try, but there's all sorts of problems with it. But I do feel like sometimes I do have a role because there's so much detail, there's so much terminology that I think for some beginning students like me who have brains that work like me, it just doesn't work. It's just too much. There's just an avalanche of detail that I need a simple story to hang it on. I know it's not as simple as that, but I remember doing that with Chris, and since then Chris has seen a lot of the stuff from the backyard, and I think he has a better sense of where I'm coming from than maybe he did back in 2016. I don't know. Let's go back to the program. So I remember showing this to Chris at some point in that trip, maybe around the campfire or something. I said, okay, Chris, so let's try this then. Is the Chelan Migmatite this kind of magma factory? Like you keep stressing that we're at depths of 30 kilometers depth with all those complicated rocks we saw in the outcrop. We're talking about the Chelan Migmatite complex. And it's not a simple magma, Chris. You're saying we're in this migmatite, which is a swirl of igneous and metamorphic textures and rock types and geometries that give us a rare glimpse at a place where we're squeezing up magmas. We're forming magmas and then squeezing them up, getting them out of that high pressure situation so that the magmas can start to develop. And he goes, well, yeah, I guess so, if you want to say it that way. Which I have been, of course. And yeah, he was emphasizing. So now we're into the details. Both Chris's group and other groups have been pulling out zircons out of some of this Chelan Migmatite, and he can pull it. I think I was asking about, how many little tiny zircon crystals can you get in like one, fist-sized rock sample. This is like on average about 300 zircons. And Chris Mattinson, who I keep talking about today, and it's appropriate, he's the main guy for the Chelan, has been able to tease out these different stages of activity, let's just call it. Again, look at these dates. This is older than the main event, older than 117 million years ago. I guess we're creating some tonalite magma. And then cross-cutting relations and other reasons and other age zircons tell us that there's some dark-colored magmas injecting into the Chelan Migmatite during that age window. Then I don't know, maybe I was asking, like, isn't there some sort of main event development here? And then there are leucocratic veins. You remember that from Bob and Stacia up on the North Cascades Highway? Those, well, these things, I guess these leucocratic veins, these white stripes going through the Chelan Migmatite, are typically happening in the 90s, between 95 and 90 million years ago, when we're down deep. So the elevator has gone down. Is that true? Yeah, 90s, right. I guess the idea is you can't get these leucocratic veins and squirt a bunch of white stuff into this migmatite unless you're down there. You got to be down there. The pressure and temperature has to be appropriate to do that leucocratic squeezing. Might be wrong on that, but let's just roll with it. And much of the migmatite is developing in that age range. Is that what we just had? Wrong time for the breeze to pick up. Yeah. So you squirt it with a bunch of white stuff when we're down deep in the Chelan Migmatite. Then the Chelan pops back up to the surface, and by the Eocene, with those two mafic dikes that we had at the road cut, then we're pretty shallow, and yes, we're in the Eocene, and a bunch of other Eocenes happening. In fact, the crazy Eocene. Okay. If you're brand new to the channel, this is not working for you because I'm using content from a bunch of different videos that we've already done. But I think to finish at this increasingly breezy chair stop, I think I want to do one more stop. And this is what I'm most excited about at the moment. This is with a recent master's thesis in the Chris Mattinson group from Central Washington University. And they have this Chelan Migmatite complex. And they cannot follow the Ross Lake Fault Zone through that stuff, just like they cannot follow the Ross Lake Fault Zone, just like Bob and Mike Eddy and Stacia cannot follow the Ross Lake Fault through the Cooper Mountain Batholith, which is nearby. And then if we leapfrog across the Ross Lake Fault, and if we keep leapfrogging across the Pasayten Fault, there's something called the Okanagan Ranges Batholith in the Okanagan block. And I'm just now realizing that Chris Mattinson has started to find, I think, some similarities between the rocks in this magma factory and then the magma itself. In other words, it appears that these two guys are related and they're still side by side. Why is this potentially exciting? Or potentially disappointing? And the answer is, some geologists think that Ross Lake Fault is a huge structure. So this is the key diagram today, which I guess is going to be a bridge to the next video, if I do make a next video. I don't know, school's starting soon. But if I do get up to this area and this area, this is the Methow block, this is the Okanagan block, and they are bounded by these two major strike slip faults, the Ross Lake Fault and the Pasayten Fault. So it's basically official. I'm leaving the Chelan block after this video, and I have left the Wenatchee block a month ago. I'm leaving the Chelan block, and I'm doing a leapfrog over the Ross Lake Fault Zone, which according to some geologists is a major leap. In other words, there's thought that there's tens, maybe hundreds, maybe more than 1,000 kilometers of offset, right lateral offset on the Ross Lake Fault Zone. If that's true, why does Chris Mattinson and his students see some connections between today's Chelan Migmatite complex and the Okanagan Ranges batholith right next door? If these two guys are related, and these two guys have not been offset, then why are a bunch of other geologists saying that this is a major fault and this is a major fault? The Pasayten, same idea. And that's how we'll quit at the chair. He goes to a book that you haven't seen before, I am guessing. Looks like this. Hey, all right. Geology of Washington and Beyond, edited by Eric Cheney, University of Washington. And this is a portion of the book that has an article, Chapter 11, a summary of the geology of the North Cascades by Roland Tabor, recently deceased, and Ralph Hagerud, who lives in Wenatchee. Enigmas. Basically, these guys have been saying, we've been working on the North Cascades for 50 years. This was written, I think, in 2016. And they're saying, here are some major questions that remain in the North Cascades. I'm going to read it with you. I'm excited. I don't know, I guess I need to start talking to Ralph Hagerud more. Ever since plate tectonic theory gave North American geologists the freedom to pursue or propose that tracts of crust had moved large distances relative to each other, most geologic observers have accepted that a significant boundary separates the rocks of the Wenatchee and Chelan blocks from the Okanagan block to the east. Hamilton proposed that a North Cascades mini-continent was accreted along a west-dipping subduction zone at the approximate position of the now younger Ross Lake Fault in the mid-Cretaceous time. Davis argued that despite the obvious presence of intervening faults, older than Cretaceous rocks in the North Cascades, in other words, in the Chelan block, once lay to the south of the Okanagan rocks and along strike equivalents. They moved to an outboard position by mid-Cretaceous, dextral, in other words, right lateral slip, on an early version of the Ross Lake Fault. Monger up in Canada placed the boundary between their superterranes 1 and superterranes 2. That's that's intermontane and then insular superterrane near the east edge of the Chelan block. And more recently, Jane Wynn in 1995 suggested on the basis of paleomagnetic observations that the Pasayten Fault is the more significant structure, with 1,000 to 2,000 kilometers of late Cretaceous and Paleogene dextral slip. And they've got detail then on their enigmas. One asking about the Pasayten Fault, another asking about how much offset has happened on the Ross Lake Fault Zone. And what's the third one? Is there continuity of crystalline rocks across the southern end of the Ross Lake Fault Zone? So I got to go talk to Ralph Hagerud. I mean, this is not that long ago that he's writing that, less than 10 years ago. And just to review then, before we quit. Ralph Hagerud, at least, is reporting that there's been significant suspicion that the Ross Lake Fault and or the Pasayten Fault have hundreds, maybe even thousands of kilometers of offset. I didn't have that before. It didn't really sink in that those two structures are way different than the Eniat Fault or the Leavenworth Fault. If I'd known that at the beginning of the summer, maybe I would have spent more time up there as opposed to dinking around with the Eniot or the Leavenworth, which have like 30 kilometers of offset each. This is different. And I think you know why I might be interested in that. If we're talking about Baja, BC this winter, and we are, how much of a role do the Ross Lake and Pasayten faults have with translating a bunch of stuff north? Wow. I'm officially interested, excited, and ready for more. Hope you are too. Let's flip you around to say goodbye. Okay, everybody, I thank you for watching this one. As usual, there's kind of an open-ended ending where I'm not really sure where I'm going next, how much deeper I'll get into a certain topic. But these kinds of connections really only happen when I'm out here with you and forcing myself to think about a few of these things. So that's where I'm going next, whether it's in the field or the weather turns south and we start just talking about it this winter in the classroom. But I'm officially excited now, really for the first time, about the Ross Lake fault and the Pasayten fault. How major are those faults? I'm not the first to wonder that, but maybe we can find some answers together. Thank you, I love you, and we'll see you next time. Goodbye from Lake Chelan area, Washington, and the Chelan Migmatite complex. Goodbye.